Lesson 3, Anatomy of an Ajax Application. In Lesson 3, we will talk about the individual building blocks of Ajax and how they fit together to form the architecture of an Ajax application. The topics we will cover are the need for Ajax, introducing Ajax, the constituent parts of Ajax, and putting it all together. Let's start by looking in detail at what we want from an Ajax application. When you interact with the traditional page-based model of a website user interface, individual pages containing text, images, data entry forms, and so forth are presented one at a time. Each page has to be dealt with individually before navigating to the next. For example, you may complete the data entry fields of a form, editing and re-editing your entries as much as you want, knowing that the data will not be sent to the server until the form is finally submitted. After you submit a form or follow a navigation link, you then must wait while the browser screen refreshes to display the new or revised page that has been delivered by the server. As your experience as an Internet user grows, using this interface becomes almost second nature. You learn certain rules of thumb that help you keep out of trouble, such as don't press the submit button a second time and don't press the back button after submitting a form. Unfortunately, interfaces built using this model do have a few drawbacks. First, there is a significant delay while each new or revised page is loaded. This interrupts what we, as users, perceive as the flow of the application. What's more, a whole page must be loaded on each occasion, even when most of its content is identical to that of the previous page. Items common to many pages on a website, such as header, footer, and navigation sections, can amount to a significant proportion of the data contained in the page. This illustrates a website displaying pages before and after the submission of a form, showing how much identical content has been reloaded and how relatively little of the display has actually changed. The combined effect of these issues is that a much inferior user experience is offered compared to that of one provided by the vast majority of desktop applications. On the desktop, you expect the display contents of a program to remain visible and the interface elements to respond to commands while the computing processes occur quietly in the background. Just like when you use a word processor, for example, you can save the document to disk, scroll or page up or down, and alter font faces and sizes without having to wait each time for the entire display to be refreshed. Ajax allows you to add to your web application interfaces some of this functionality more commonly seen in desktop applications and often referred to as a rich user experience. To improve the user's experience, you need to add some extra capabilities to the traditional page-based interface design. You want your user's page to be interactive, responding to the user's actions with revised content, and be updated without any interruptions for page loads or screen refreshes. To achieve this, Ajax builds an extra layer of processing between the web page and the server. This layer, normally called an Ajax engine or Ajax framework, intercepts requests from the user and in the background handles server communications quietly, unobtrusively, and asynchronously. By this we mean that server requests and responses no longer need to coincide with particular user actions, but may happen at any time convenient to the user and to the correct operation of the application. The browser does not freeze and await the completion by the server of the last request, but instead lets the user carry on scrolling, clicking, and typing in the current page. The updating of page elements to reflect the revised information received from the server is also looked after by Ajax, happening dynamically while the page continues to be used. This represents how these interactions will take place. To see an example of an Ajax application, let's take a look at Google Suggest. This application extends the familiar Google search engine interface to offer the user suggestions for suitable search terms based on what he has typed so far. Each time a key is pressed by the user, the application's Ajax layer queries Google's server for similar search phrases and then presents the returned data in a drop-down box. Along with each suggested phrase is listed the number of the results that would be expected for a search conducted using that phrase. At any point, the user has the option to select one of these suggestions instead of continuing to type and have Google process the selected search. Because the server is queried with every key press, this drop-down list updates dynamically as the user types, with no waiting for page refreshes or similar interruptions. This shows the program in action. You can try it for yourself by following the links from Google's homepage at this link. Next, let's identify the individual components of an Ajax application and see how they work together. Let's examine the components of an Ajax application one at a time. The XML HTTP request object. When you click on a hyperlink or submit an HTML form, you send an HTTP request to the server, which responds by serving you a new or revised page. For your web application to work asynchronously, however, you must have a way to send HTTP requests to the server without an associated request to display a new page. You can do this by using the XML HTTP request object. This JavaScript object is capable of making a connection to the server and issuing an HTTP request without the necessity of an associated page load. With traditional web pages, when you issue a server request through a hyperlink or a form submission, the server accepts that request, carries out any required server-side processing, and subsequently serves you a new page with content appropriate to the action you have undertaken. While this processing takes place, the user interface is effectively frozen. You are made quite aware of this when the server has completed its task by the appearance in the browser of the new or revised page. With asynchronous server requests, however, these communications occur in the background and the completion of the request doesn't necessarily coincide with a screen refresh or a new page being loaded. You must then make other arrangements to find out what progress the server has made in dealing with the request. The XML HTTP request object possesses a convenient property to report on the progress of the server request. You can examine this property using JavaScript routines to determine the point at which the server has completed its task and the results are available for use. Your Ajax armory must therefore include a routine to monitor the status of a request and to act accordingly. So far as the server-side script is concerned, the communication from the XML HTTP request object is just another HTTP request. Ajax applications care little about what languages or operating environments exist at the server, provided that the client-side Ajax layer receives a timely and correctly formatted HTTP response from the server. Everything will work just fine. It's possible to build simple Ajax applications with no server-side scripting at all, simply by having the XML HTTP request object call a static server resource, such as an XML or text file. Ajax applications may make calls to various other server-side resources, such as web services. Once notification is given that an asynchronous request has been successfully completed, you may then utilize the information returned by the server. Ajax allows for this information to be returned in a number of formats, including ASCII text and XML data. Depending on the nature of the application, you may then translate, display, or otherwise process this information within the current page. An Ajax application will be required to carry out a number of other duties too. Some examples include detecting error conditions and handling them appropriately, and keeping the user informed about the status of submitted Ajax requests. What if you want to design a new Ajax application or update a legacy web application to include Ajax techniques? Well, first you will need to decide what page events and user actions will be responsible for causing the sending of an asynchronous HTTP request. You may decide, for example, that the action of moving the mouse cursor over an image will result in a request being sent to the server to retrieve further information about the subject of the picture, or that the clicking of a button will generate a server request for information with which to populate the fields on a form. JavaScript can be used to execute instructions on occurrences like these by employing event handlers. In your Ajax applications, these methods will be responsible for initiating asynchronous HTTP requests via XML HTTP request. Having made the request, you need to write routines to monitor the progress of that request until you hear from the server that the request has been successfully completed. Finally, after receiving notification that the server has completed its task, you need a routine to retrieve the information returned from the server and apply it in the application. You might, for example, want to use the newly returned data to change the contents of the page's body text, populate the fields of a form, or pop open an information window. This shows the flow diagram of all this. While it is essential for a complete understanding of Ajax to understand what role each of the individual components plays, thankfully it is not necessary to rewrite all of your code for each new application. Your Ajax code can be stored as a reusable library of common Ajax routines, ready to be reused wherever they may be needed. There are also many commercial and open source frameworks that you can use in your projects to do the heavy lifting. In this lesson, we discussed the shortcomings of the traditional web interface, identifying specific problems we want to overcome. We also introduced the various building blocks of an Ajax application and discussed how they work together. You can now test your knowledge in the quiz area, access the scripts we learned in the lab, or go through the lesson again. The choice is yours. Thank you for choosing Sam's Teach Yourself.